Hello everyone, I'm Dipali Chandel and I welcome you all over here for tutorial regarding basics of NLP using spaCy. So what is spaCy? spaCy is a free open source library that parses and understands large volumes of text, and this library was written in Python and Cython languages, and its main developers are Matthew Honorable and Inas Montani. They are also the founder of company Explosion. Now let me introduce you to the topics that we're gonna cover in this tutorial. So we're gonna do comparison between spaCy and NLTK. Then we're gonna understand what are the features of spaCy. Then we're gonna know what are the basic operations we can do using spaCy, about architecture of spaCy, about NLP pipeline of spaCy. Then in detail we're gonna do all the basic operations of spaCy. Okay. Then vocab hashes and lexemes. Then we're gonna understand NER with transformers. Then one project which is text classification using spaCy. Now, what is NLTK? NLTK, as we know, is root of NLP. It provides lot of operations like tokenization, lemmatization, stemming, named entity recognition, etc. Few years back, it was base library for all NLP operations. But there are a lot of limitations associated with this library as well. And what are those limitations? Like NLTK is more academic in nature, it is slow, it has low accuracy as compared to other libraries, it does not provide neural network support, does not provide integrated word vectors, it provides lot of solutions for any problem, okay, or it provides lot of algorithms for a particular problem in NLP. So we have to choose out of all those algorithms or solutions. So that is a huge task. That's why. And one more thing over here, like it only splits text by sentence without analyzing the semantic analysis behind that. So these were some, we can say, limitations of the NLTK. So that's why NLTK is not more preferred over spaCy. Now let's understand what are the features and advantages of the spaCy. Okay, so it provides tokenization for around 55 plus languages. It has statistical models for 17 languages. Then it comes with pre-trained statistical models and word vectors as well. spaCy provides we can say one best solution for any particular problem. So every time we don't have to think which solution we need to choose like we do in the NLTK. Okay. Now spaCy is fast as well. It interoperates seamlessly with TensorFlow, PyTorch, and Scikit-learn, Gensim, and other libraries. Okay. Now spaCy also access at large scale information extraction processes. Okay, and it has a high memory optimization as well. spaCy is designed to help us to do real world problems like to gather real insights and to build real products. Now it's also easy to install and its API is simple and productive. So these were some features and advantages of the of the spaCy. Now furthermore, if we see, you can see over this diagram like timings. According to the timing, NLTK take more time for the word tokenization as compared to spaCy. Then if we look at sentence tokenization, so spaCy takes more time as compared to NLTK. Now again we look at part of speech tagging. So NLTK take large time as compared to spaCy. Okay. So these were some, we can say, differences between them both. Now going further, so over here we have three units. First of all, the language, the vocab, and the doc. Okay. Now, so what happens firstly, when we, if you want to look at the architecture. So first of all, we can say over here we have to select the model, like in which language your text is. So let's suppose our language of our text is English language. So we have to load the model for the English language. Okay. Now when we load the model for the English language, now the text go over here to the tokenizer and to this NLP pipeline. Now what happens? The language class, this language class processes the text and creates a doc object for it. Okay, and this object is stored as a variable, usually known as NLP. So this variable NLP denotes object of object that is created because of this unit, language unit, or we can say this language class. Fine. Now after that, what happens? Now this tokenizer, let's see this tokenizer. So what does this tokenizer do? This tokenizer segments the raw text and creates doc objects from the words. So basically all the sentences of the text will pass through this tokenizer, and this gonna segment complete text into the words and gonna create the objects for the words. Now over here again, if we look at the right hand side of the language class, then the text will pass through this complete NLP pipeline. Now over here what will happen? First it will okay, let's see what is the process of all these we can say what are all these processes over here. So text categorizer. So what is text categorizer? It predicts the categories for the complete text. It predicts the categories for the complete text. Then what is tagger? Tagger used to do pause tagging. What is pause tagging? Part of speech tagging. Like we have a particular word, so what in a sentence we have subject, or we can say like not subject, noun, verb, adverb. Okay, so all these tags are all these tagging is done by tagger. Okay, after that we have dependency parser. So what does this dependency parser do? Basically on which subject we can say like which subject is dependent on which object. That means this dependency parser sees like how the words are dependent on each other. This dependency parser gives us relation among the words. Okay, now what does this entity recognizer do? This entity recognizer try to recognize the entity from the sentence. Like we have a particular name of the organization, so that name belongs to org entity. Now we have a name of a person, so that name of that person belong to person entity. Similarly, if you have a date, that will belong to date entity. Okay, then if you have time, so that belong to time entity. If you have value of a money like $10 or $100 or 100 million like this, so that will belong to money entity. Fine. Now after that, all the words, okay, all the tokens that will come, words are known as tokens, and punctuation also. Like what are tokens? When we segment the sentences into the parts, that will become words. Then those words will become tokens. Okay, now those tokens will pass through, will come to this vocab class, and over there if those words are not present here, so those new words will be added in it with their information which is coming from NLP pipeline. Okay, like their among relation between those words and with their tags and what is their entity, with all these details that will be feed over here. Okay, that will get feeded over here. Now what will happen? Let's come to this we can say this unit. So what will this unit do? This unit, doc unit, this we can say this is container for all the linguistic annotations for all tokens. What is linguistic annotations? Like part of speech tags. Okay, then categories, entities, all will be stored here. Fine. Now let's come to this part, string store. Now what does string store do? This gonna map the string to hash values or hash values to string back. Now suppose I ask you what is the hash value for, like this string store will give me hash value for word, let's suppose bubble. A word bubble is there, so this string store will give me hash value for this value for this word bubble. Now I want to see what is the word against this string value, like vice versa, right? So it will give me again the word bubble. That means what is hash value? Where does we can say address of that word in the memory? Okay, in the architecture of the spaCy, what is the address? Okay, what is the unique ID? We can say what is the unique ID for that word. So this is stored over here. With the help of that ID, we can access that word, and with the help of that word, we can access that ID, the ID for that. Okay. Now, what is morpholizer? What does it do? So basically, we can say it decomposes the word into the prefix, suffix, and like infinitive, and any other decomposition of that word is done over here in the morphology class or unit. Okay. Now, going further, all these will add up. Now, see, from this words will come with certain details. From here also word will come. From here also word will come with the entity, with their tags, with their relation with different words. Okay. Now this doc vocab will again give us give information to this vocab class. This doc unit will give information regarding the word or the token to this vocab class. And now this vocab class will further pass all the information and that word to the, we can say, morphology class. Okay. And now with the help of that word, we can see what is the hash value for that word, or with the help of that word we can see with the help of that hash value we can see what is the word against that hash value. Fine. So this is done with the help of string store class. Fine. Now let's moving further. So what is token and span and lexeme? Okay. So what is token? So what is token? So token is I'm talking about this unit. So what is token? The output that we get after the tokenization process, the word, the punctuation symbol, or any white spaces, that is token. Now, okay, what is lexeme? Lexeme is the word which doesn't have any tag, okay, which doesn't have any part of a speech tag, which doesn't have any entity, which doesn't have any relation with any other words in the text. That is lexeme. And what is span? We can say slice from the doc object. That is span. Slice from the doc object. That is span. Okay. Now, I hope guys this architecture was clear to you. Now let's proceeding further. So moving on to pipeline of the NLP. So over here, first of all, when we load the text, okay, when we load the text, it goes to the tokenizer. So what does this tokenizer do? It creates the word, it tokenizes the text. Okay, after that, this tagger do part of speech tagging. It creates the tag for each word or each token that we get as an output after the tokenization process. Now what does this parser do? This parser find out the, we can say, relation among different words in that text. Okay. Now what does this NER do? What is the output of that NER? The output of that NER is the entity name that we get after the NER process. Okay. Now finally we get the processed document or processed text. Fine. So this was the NLP pipeline with the help of the spaCy. Now further, in the next class, we're going to cover some basic operations that we can do with the help of the spaCy. Now guys, if you want to get to know about NLTK, then you can see one of my previous videos that I uploaded already on the channel. So you can go through that to learn more. Okay. Thank you very much.